All right. So next talk we have is Michael Oborne giving us an update on Mission Planner. So over to you, Michael.
Okay, so screen sharing's done. And I'll just start video as well. There we go. Are you ready to go, Tridge? Started recording?
Yep, all good. Go for it, Michael.
Okay. Cool. Okay, so my talk is about basically just a Mission Planner update. Yeah, so a lot of what I'm going to be discussing has actually already been discussed in one form or another, either whether it be Leonard, Andy, Tridge, like pretty much everything I'm going to be saying has already been mentioned in some form. So I'll probably reference it throughout to guide people watching this to view other people's videos. So please feel free to chime in as needed, or if you have any questions throughout. So all good. Okay, so the new feature list for the past, I think, close to 2 years, I think, because last year I didn't actually do a speech, but predominantly these are stuff within the last year. So all the stuff at the top of this list, I'm going to be going through a little bit more in depth, and the stuff towards the end of the list, I'm going to gloss over fairly fast towards the end, but I'll give you a rough idea where to find it and what it does, just a very brief description of it. Okay, so first thing, plugins. So on one of my previous speeches, probably 2 or 3 years ago, I would have talked about Iron Python plugins. So that feature still exists in Mission Planner. What has been added since then, though, is the ability to add C# plugins. So these are compiled at runtime and basically give you full access to all the Mission Planner internals. So what I'll do is I'll go through a very basic demo plugin and basically show you what it does, how it would work. And there's a link here to where they are located on GitHub. And right down the bottom here, there's an example plugin in the Discuss forum. So the example I've listed here is actually the initial params calculator, which is a community contribution. So I just accept pull requests to that as required and accept it in, and it ships with Mission Planner. So where this works and where this doesn't work. It works on Windows, Linux, and a Raspberry Pi. It does not work on Android or iOS. The reason for the not working on Android or iOS is actually App Store restrictions about basically dynamically compiled code at runtime are not allowed on those platforms, security risk and all. So I'll just open this plugin. So what I'll do is I'm going to go through example 6. So what we'll do is we'll just have a quick look through this. So basically the structure is very similar to them all. So 71 lines of code. And I'll show you what this does after we go through the code a little bit. So all this stuff at the top is, as you can tell, fairly self-explanatory. The init code, so it's actually run. So what this actually does, it creates a tool strip menu icon called change icon description, adds an on-click event, so when the button is actually clicked, and then it tells it where it's going to add this on-click event and the button to. So in this case, it's a flight data menu map, and we're adding it to the items, and we're just adding it. And then down here is what the button actually does. So in this case, all what we're doing is changing the description Mission Planner shows on the flight data menu map. And basically you can change it to anything you want. So in this case, we have the altitude, the alt unit, airspeed, speed unit, the SysID, sat count, HDOT, and battery voltage. So to give you an example of that, so I'll just start Mission Planner. Okay, now because these are dynamically compiled plugins, they do take a little while to basically compile at startup. I know now that they've actually all finished loading. I can see it on the back end screen. So there's 2 features here. One of them is a hidden keyboard shortcut, Control P, which will actually load this screen here. So basically this gives you a rough idea of all the plugins currently loaded. And if you look at map icon description, which is our example 6, that's that one we were just looking at for the source code. So that's compiled in and running at the moment. There are a few others here, like the initial parameter. That's the example that I gave you a community contribution, the generator. So that's for a generator plugin that dynamically loads as needed. And then there's a few other ones like HUD, the ability to turn off things. Most of these are all examples, so it really depends on what example you're going for. And I try to do a little bit of everything in there. So if you did want to add a custom button or anything to an existing mission planner menu, you can add that as you require. So what that actually did, so if I right click here, you'll see down here, change icon description. So that's the feature, that simple C# script added. So if I click that, and there's our default placeholder. So basically using this here, I could change this to whatever we wanted to add, and basically that's it there. So to actually make that show up, let's just actually load something so you can actually see it. Okay, so that's basically it there. So I can change that to display anything I want. And as for fields to substitute, everything you see in the status tab, if you write it in brackets as you see it here, you can inject it into the description here. So it would be the same for all aircraft. So if you were connected to multiple copters, planes, whatever, it would display the same thing for all of them. So yeah, height, speed, the system ID, satellite count, HDOT, and voltage. So basically that's a very brief example of the stuff that you can do with plugins. Like, dare I say it, so if we go, I'll just quickly show one of the other ones as well. So one of these ones in here was HUD. So all what HUD does is it adds a menu over here for HUD items. So using this, you could literally turn off any of the options on the HUD. So say you didn't want to display the heading, it disables the heading in the HUD. So this is all, and the examples on GitHub as well. Obviously, this may or may not have use, but it gives you a good idea and example of how you can use it and what you can do with it. So I'll just close that one down. So that's an example, very simple example of a plugin. There are plenty more examples in here, depending on what you wanted, like the HUD on off. That was the example, that extra HUD one I showed you. So again, when loaded, add a button, the options we want to do, and then some code to actually read the property and set a true or false depending on if I want to show it or not. Very simplistic. So one thing I probably should add as well is there is a loop as well. So if you wanted something running regularly at a fixed interval, you could actually run it, put your code in the loop. So whereas these loaded and init are obviously fire once properties. The only thing I might add for those that are looking at doing this is quite often these are not loaded on the UI thread. So depending on what you want to do, you may need to basically marshal it onto the UI thread, but I think that's more an advanced topic depending on what you want to do. The examples will give you a rough idea of how to do it in the first place.
Hey, Michael?
Yes?
This is Tom Pinger. So you said this this is loaded at, or compiled, I guess you said at runtime. Does that mean that Mission Planner does not need to be recompiled to take advantage of this? You just drop the CS file in?
Correct. So 100% compiled at runtime.
Okay, so the stock, whatever you download from the internet and installed Mission Planner major release or whatever, you just make your own CS file, add those couple lines, and yeah, that's nice.
Yep. So it's very similar. Like I said, the IronPython has been like, it's just Python. It's evaluated at runtime effectively, whereas this is technically compiled at runtime. So unlike IronPython, you could actually basically change it, rerun it, change it, rerun it. This here, it's more as Mission Planner starts up, so you can't change the code and then just expect it to change. You'd have to actually restart Mission Planner between your debugging sessions if you wanted to. There are other options about just compiling it into Mission Planner if that's your preferred choice in the first place. But this is just an example of how to do it at compile time. And the initial parameter calculator, the community contribution, we're quite a few, 268 lines. And so for what people, this is actually a tuning guide from Leonard, I think it is. that basically someone contributed. So basically just asked a few questions. So initial parameter, so air screw size, battery cell count, fully charged voltage, discharge voltage, and using those numbers obviously can calculate rough rate limits and PID calc values and all these other stuff. So this one, it's implemented as a view only, and then you apply it secondary. So yeah, and to actually initiate this one, so this is shipped in Mission Planner now. To actually initiate this, you would have to press Alt A on a mission, pretty much any Mission Planner screen, Alt A, because it's actually taking a keyboard shortcut callback, and you could actually basically initiate that from anywhere in the application. So, okay. So that's pretty much plugins sorted out.
Michael, sorry, one more question before we move on. So this seems really amazing. I didn't know about this at all. So this is kind of blowing my mind. This is awesome. Is there a way that you're able to add in runtime reloading of the plugins? Because that seemed like a big development.
Technically, yes. It wasn't sort of in the initial scope, but yes, it's definitely possible. Probably the biggest problem is actually unloading the file after it's actually been loaded initially, versus actually you could load it multiple times, but obviously that gets quite messy. Whereas unloading it is probably going to be the bigger issue, just because of the way C# works and the app domain works. So I'm not saying it's not possible, but I would need to look in. I'm not worried about the loading. It's more about the unloading of the plugin, which is I'm more concerned by.
Yeah, when you showed your Control P and you had that chart there, in other apps I've seen, usually you can do something like enable or disable given plugins, and then that's usually how they, if you disable it, re-enable it is how you refresh.
So basically, this does have an enable disable option, but if you click that after it's been loaded, it wouldn't actually disable it in this run. So I'll just open that again because I know they finished loading. So these purely just disable it from compiling at startup. Currently, it's not live. So yeah, that would have to be a future edition, I think.
Cool.
Okay. So, basically for that plugin screen that you saw, just to show the current status, is Control P. That will probably end up moving to the Mission Planner settings screen in the very short term. It's actually been in, this option's been in there for quite some time. If you look at the commit history there, at least over probably 9 months ago sort of thing, a lot of this stuff was added, so possibly older than that. Like I said, the caveat being Android and OS, this is not possible. Okay, so the next one is just a few additions to the log browser. So I'll just, and this will be another quick demo. I'll be doing quite a few demos today, so data flash log. I'll just pick a log. It doesn't really matter what at this point. Let's pick this one. I don't know if it was a good example. So basically the extra features in here are around the show parameters, this option just here. So this will basically show the parameter tree, and so you can basically view all the parameters that were on the vehicle at the time. Currently this, if there's a parameter change through the log, it'll actually display the final output value. So the value at the end of the log is the value that will be showing here, not the initial turn on values. There is, obviously you could do some tweaking around this. It's hard to know what people sort of want though in that respect. So, but it's a good idea. And there was a few bugs Randy spotted here, which are now resolved, as you can probably see by me moving the mouse around at the moment. So there's, yeah, it's just basically gives you an easier way to get access to this stuff to be able to view it in the first place. One of the other things is all about the description. So the metadata down here at the bottom of the screen. So basically, as I mouse over stuff, it'll basically give me a description of what it is. And the last one is probably, I'm going to pick Barrow because I know that's a good one. So the ability to graph, in older versions of Mission Planner, everything was basically put on a single axis. So now that we have this metadata, basically, as an example, you pick altitude, it knows it's in meters. So I tick that, and basically we got the unit of meters. If I tick pressure, obviously a different unit, so it will add it to a different axis. Temperature, different unit, it'll add it to a different axis. So there was obviously, like, we're at the integer level here, like single digits, here we're at double digits, and like you look at the different scales here, they're quite vastly different. So now the ability to go for like Barrow plus GPS here and have graph altitude, so all the altitudes will be on the same axis. The right click option still exists, and that will work exactly the same as well as it previously did. So it's really just about adding the individual axes based on the unit type from the log metadata, and the actual display of what it is as well. It's like obviously looking through some of the EKF stuff, knowing what VN is, velocity north, but estimated velocity north component as described down here. So it really just giving a more novice user just more direct access as to what that value is in the first place and having it readily available. Okay, so that's pretty much the changes for the log browser.
Oh, so Michael, what happens when you double click on one of those log entries on the right side?
Oh yes, an addition from Tom. So let's just open a log again. So basically Tom, quite a while ago, added the ability to scale things. So if I pick, say, let's pick altitude. So I'll double click this and we can actually apply an offset or a scalar that Tom knows all about. So I picked altitude in this case. So if I times that by 10, this is a really bad example, but, oh, hang on. So, and let me guess, it's not going to play get ball now. No, it's not. I think it might actually work this time. Okay, so it looks like there might be a bit of tweaking still involved here.
Well, no, you click, so uncheck it and then check it again so it redraws it.
Yeah, that given its camera, that is the right altitude. So might have to look into that one a little bit, I think. But the intent obviously is to be able to provide scalars, offsets, similar to what MAVProxy could do in that respect. And of course, I would have talked about this previously, a lot of the MAVProxy graphs are actually here, and this list does actually support expressions. I don't expose this to the end user, but in the backend, Mission Planner does actually support a lot of the MAVProxy expressions for MAVGraph. It's just not exposed in the front end. Okay. So moving along. Okay, so UAVCAN and AP proof. So after the excellent talk by Tom yesterday, basically he illustrated a lot better than I could some of this stuff in here. But what I'll do is I'm just going to briefly go through just a few of the things that are options in this screen, and basically how you can use it and what you can do with it. So on my desk, I currently have a Cube Orange with a HERE3 attached. So I'm going to connect to my Cube Orange and the SLCAN port, set up optional UAVCAN, and in this, so I'll probably take one step back and give you a bit of history. The reason there is two buttons is actually from back in the Cube Black days. So when we were using a single serial endpoint, you actually had to connect to MAVLink first and then click one of these buttons to actually basically turn the MAVLink stream into SLCAN mode. On a Cube Orange, when you pick the SLCAN port, it doesn't actually matter which one you pick. They both do the same thing. So that's purely a legacy thing. And yeah, it's just legacy. So I'll just connect here. So this has got my Cube Orange has master on it. And as you can see, I've got a HERE connected to it at the moment as well. So A lot of this screen is basically, as you would have seen in Tom's talk, the menu to do update parameters, to actually restart the node, to update. So update actually will search the internet. I think KubePilot is the only vendor that actually has anything, firmware URLs for this. So in the background, all it does is uses the name of the node plus the hardware version ID to pull a firmware. And once it's downloaded, it will check the software CRC to see if it needs uploading or not. So there's the update and the update beta, and then the CAN pass-through is another option added for the Here and the Here Pro, which basically allows direct access via CAN, well, direct access to the uBlocks module over CAN, so you can do firmware updates of the M8P or the F9 or whatever other system you're using, so long as the firmware has been written to support that. So one of the biggest things, debugging CAN devices. So down the bottom here, you'd have the node status, the debug text that the node is actually spitting out. In this case, there is none. I've got the 1.7 here firmware on this, so all of this debug text has been removed. If you have a 1.5 or 1.6, there'll be debug text probably every 5 seconds it is, telling you the load average and currently missed CAN frame output. But as of 1.7, this no longer exists. So what I'm going to do is I'm going to open the inspector, and it will open a screen like this. So what this helps with is if you want to check that the node is actually working and outputting what you expect to do. So in this case, I'll pick the Here, magnetic field. So magnetic field, I can see the magnetic field changing. If let's graph that. So one query I have here is why pick points over time? And the reason for picking points over time is because it depends on the update rate. So as an example, I can see that we're doing 70 frames per second here, around 70 Hertz. So I'm leaving that in the operator's hands as to how long it is. And this way I can allocate memory at the start. I know how wide the graph's going to be and other things like that. So obviously you could pick 5,000 in this field if you wanted to. It really doesn't make any difference. Now, because I picked magnetic field and there is actually 3 single values in there, as I graph it, it actually shows all axes. So let me just rotate this a little bit so it actually does something useful. But yeah, so you can see the data and basically do whatever you want with it. So that will actually stay there. If for an example you had a cube orange, if you opened another copy of Mission Planner, you could connect via MAVLink and do MAVLink stuff. Currently, Mission Planner, you can't have both SLCAN screen and MAVLink connected at the same time. Technically, it's possible, but at the moment you cannot. So you should be able to, using one cube orange, you should be able to basically talk to it with MAVLink to do control whatever you need to do, and then also have SLCAN connected to basically monitor what's happening on the SLCAN bus. So where this might be handy is if I just close this and open this, you'll see that I'm sending both actuator commands and also raw ESC commands. So if I was testing ESCs and wanted to see the actual command being driven out the CAN bus, I could do that, or basically safety status, light commands, or whatever else you wanted to do. So currently blue, green, red is set to 0. Oh, spiked there for a second. So this would basically just, so you could graph to see that there is valid output coming out of it. And I can tell that this is working because there's a yellow flashing cube, yellow flashing here on my desk at the moment. Okay, so, and then safety status and other things like that. So one of also the other things is the approximate bandwidth on the bus. So I will say SLCAN is a very inefficient protocol. So basically that is the that is the message bandwidth on the bus, not the actual bandwidth on the bus. It'd be getting close to double that by the time you got to the bus, and then possibly double plus a bit for actual the SLCAN packing. Complex subject, and I'll just leave it at that for this point in time. So one other thing that might come in handy is this subscribe option. So if we pick, I'm going to pick, well, it doesn't actually matter what I pick here, but so that we've got the here 3 here with a, actually here 2 with the fix. So I'll subscribe, and this, what this opens is this screen here. And then we can pick a message. So say I wanted to see data from this, so let's pick fix 2. And what this does is this will just keep scrolling through data. And as you can see there, the time USEX is just slowly climbing. So to show one message, we do 100. I'll change it to 0, sorry. And basically all the number does is how many lines you wanted to display above that. So the actual output format here is JSON. If you see just there, there's the packet start and finish just at that point there. And so you could copy and paste that into an external application or whatever else you wanted to do or needed it for. So as you increase this number, the number of packets in history changes as well. So it really depends on what you want to do. There's a good example with MAVField, just constantly changing, although you probably can't see that via Zoom. Okay. So, so that is basically the principles of the UAVCAN screen. There's been a lot of work, especially Sid has been certainly fairly busy on this topic. And I know in the future, CAN-FD will certainly be one of those topics that will be integrated into this as well. Obviously, the amount of work involved there is unknown at this point, but it will be coming soon. And yeah, we'll see how it all goes. As for the update and parameters, Tom gave a good presentation of that yesterday. So it's should be all fairly straightforward. Okay, so I'll just close that. Oh, actually, one thing I will do. Okay, so from a debugging perspective, one thing, like I know UAVCAN GUI tool doesn't actually support this, but so before you connect, there's an option up here that says log in the top right corner. If you tick that and then connect, it will actually log the SLCAN traffic to a log file in the normal Mission Planner's log directory. This is great for debugging and post-processing logs later on. Although Mission Planner doesn't directly support processing those logs, I do have apps in the background that do support processing those SLCAN logs into, say, JSON files or Excel files, depending on the data format, and actually analyzing the data afterwards. Mission Planner doesn't support that out of the box, as it's probably more advanced topic, but if you needed a SLCAN log off the bus while viewing the data, so you could possibly review what you saw during the logging using Inspector as an example, you can do that later on. So all good. Okay, so obviously the future, like I've written here, is FDCAN with basically the 64-byte message frames instead of 8-byte message frames. I think that will certainly improve things on the bus with a heavily saturated with ESC data, GPS, RTCM data, and other things on the bus. CAN is certainly getting flooded. So CAN-FDs will definitely be an improvement in that field. Okay, so the next thing, MAVFTP. So MAVFTP has definitely improved the speed of connecting and other features as well, whether it be log download, scripting, Lua REPL, and as I know me and Trish were chatting before the call before this meeting today about basically the way the sys works and future support of mission and param upload and download of mission. Obviously, we already have param download via MAVFTP, but the ability to upload params and missions in an atomic operation obviously opens up many windows there. Now, I'll very quick demo. I think most people here will already know how to do this, so I won't waste very much time on it. So I'll do to real hardware. We'll connect via MAVLink. So this process here will download the parameters via MAVFTP right now. Very quickly, all parameters done. This is USB, as Trid showed yesterday in his talk about over a SIK radio versus USB. And if we go config and then MAVFTP, basically we can see the listings of everything on here. So what you're looking at now is actually the sys. So this obviously this incorporates both a bit of what Trid said with basically this is at sys, at mission potentially coming, at param potentially coming, or possibly a virtual route, which we were talking about this morning, where Mission Planner would show one route and these would be automatically listed inside instead of showing you 3 separate folders as it is right now. So this ties into where Tom was, basically all these folders using basically CAN stats, UAVCAN stats, and other threads tasks. If you want more information on that, have a look at Tridge's chat regarding this one. There's lots of good information. So ROMFS, I might have got ahead. Technically, ROMFS doesn't work in ArduPilot. I don't see any reason why it shouldn't, but currently it does not. I'll just leave that bit of fruit hanging there somewhere. And then
yes, the directory listing doesn't work. The ROMFS itself works. You can fetch files if you know their names, but you can't at the moment do a directory listing inside ROMFS.
Yeah, cool. Yeah, so basically logs, everything you'd expect, EEPROM backups, or FRAM backups, sorry, and the terrain data. If I'd use this kit to do REPL, there'll be a scripting directory in here as well, and many other directories depending on use case, obviously. Obviously, upload, download is everything you'd expect. Download, burst, download, upload, delete, rename, the ability to select multiple files, delete them, and the ability to drop and drag from Windows into this directory works as well. So if you just wanted to drop and drag, the only caveat with drop and drag is the UI does technically hang while it's transferring. That's just, I'm sure many of you have probably come across this in Windows in general. If you drop and drag the wrong thing into the wrong place, things just seem to sit there for a while. Mission Planner is no different. That's a property of Windows. So yeah, just the way it is. Okay, so that's MAVFTP in a nutshell.
A quick question.
Yes.
Using MAVFTP for refresh of params yet?
Currently, no. There's no reason I can't add it. I already obviously have the code to do that on Connect, but I will be adding that. I'll probably end up keeping a status of if I was able to do it on Connect, and then if it's refreshed in the future, I'll basically pull it by MAVFTP again, using that status from the initial Connect. That will probably be the plan forward, I think.
Great.
Yeah. So definitely future work. Yep. Okay, so next. So with all this FFT talk from pretty much every speech prior to me, this is something that I've been working on in the background. Hasn't been a lot of public exposure to it. So Mission Planner has the standard FFT screen. What this does is it actually does a FFT over the entire log. It does not display it in a logarithmic scale. It just displays it purely as an aggregate of the total magnitude of all the data in the log. So there is a windowing function over that. It's running a Hanning window over the entire log, and then basically averaging all of the samples in that log into the FFT screen. So I've done a chat about FFT in prior years, so I'm not going to go over that one again. What I'm going to do is do an example of the new spectrogram screen. So the FFT screen shows it over the entire log, so it's not time dependent, whereas the spectrogram shows the FFT over time. So as an example with what you're seeing on screen right now, you're seeing a log of the Excel one on the X, Y, and Z axis, and you're seeing it over time. And so you've got a pretty good rough idea of when the props basically ramp up there. As for the banding in this data, I have a feeling that actually might be an IMU issue with this specific board, or there's some kind of really weird resonance in the frame, but I don't think it's resonance. So I'll just quickly, to get this function, Control L, I will be moving this probably to the setup advanced screen, but currently it's under Control L and is in beta and has been for probably 2 or 3 months. So I'll just start Mission Planner again. So Control L brings up a screen that looks like this. Load a log. I'm going to pick a FFT from a Durandal. I'm not quite sure where I got this log, but it's off the internet somewhere. So here's just an example of, like I said, I don't know where this log actually came from, but it's an example of what looks to be a nice constant resonance frequency depending on very specific frequencies. So you can zoom in here if you want to. Because of the way it works, it's probably not the easiest way to view it, but it does, undo zoom all, does display it on each axis. And you can change basically the Excel 1, 2, 3 or gyro 1, 2, 3. And you can also change the min and max scale. So this is in dB, unlike the other, so it's effectively a logarithmic scale. The color is based on a logarithmic scale. So obviously the red being high amplitude and the purpley blue and gray being low amplitude. So that's one example of a log. I'll just go through a couple of the logs. So let's pick cube orange FFT. I can't remember which log this is. So this is predominantly a fairly big flight. You can see the primary data. So this same log using the old FFT screen would just show basically banding around what, 100 hertz and 200 hertz. So it'd be probably heavier around 100 and slightly lower around 200 hertz. I'm guessing there a little, and then slight rise at maybe 400 hertz on the x-axis, then the y and the z-axis. So the z-axis is a good one. You can see predominantly in the just under 200 hertz range. So this ties into everybody that's talked about FFT in my prior chats. Yeah, it's all related ultimately. It's just this is more for post-processing versus the real-time harmonic notch or any of those other FFT stuff. So, and I'll just let's pick this one here as well for as an example. I'll click update to actually update it. So here's another log as well. Again, you can see the banding of red, and you can tell where the motor started spinning up. Yeah. So all of this is a FFT, basically a sliding window FFT. Can't remember how often it's sliding, but it might be 1 or 2, 3 samples for each time slice. So sliding window over that using a Hanning window. Okay, so again, so to use this, you need to do the batch sampling, enable batch sampling. Exact same data as the old FFT screen, but requires batch sampling data to generate this. Okay, so that is basically an example of the new spectrogram, which is just displaying FFT over time. Potentially good if you had it on a harmonic table of some description, and like I know we have test data showing frequency sweeps, and using this to actually see the frequency sweep and the harmonics of the frequency sweep on different devices. Okay, so probably one of the biggest ones, Android iOS support. So this one definitely wouldn't have been possible without QPilot. So if you actually have a look in the Git history around this, you'll see the Mono sub repo was added back into Mission Planner. Well, Mono sub module was added back in Mission Planner back in 2018 sometime. So it's been a long time coming, and it's really just a time factor here. So for those that don't know, Mission Planner is available on Android. There are still a few issues. I'm not going to deny that at all, but it is available on the Play Store right now. And so Play Store, just search for Mission Planner, you'll find it. Normal icon, and it looks just like Mission Planner on Windows, just on Android. And there is also an iOS version, iOS and an OS X version. However, there's been limited testing, and you'd have to sideload that onto an iOS device at this point in time. Should you be interested in doing this, basically this second link here, so it's actually part of the GitHub CI, so I'll just click that to show you where to get it. So currently, Mission Planner, go to the Actions tab, and this is all the CI tasks. So we got the Android build, we got the .NET build. So .NET build is the Windows build, Android is Android build, and OS X includes both the OS X and iOS build. So what you do is you download the artifact down the bottom here, and inside there would be the packages that you could actually sideload onto a phone or to your OS X device, Mac OS X device, and basically give it a shot. So please give it a shot. There has been limited testing on iOS and OS X, but feel free to give me some feedback. I don't expect it to be perfect by any means, but feel free to give it a shot. Okay, so now the technical on how it works. So the way this actually works is, so from the lowest level, it's actually running Skier as the rendering agent, and this is tied with Skier Sharp, which is a C# basically implementation of the Skier backend. Android runs Skier native, and iOS is running it native in terms of the rendering engine as well. But Skier is a project maintained by Google, so Skier and Android are very interlinked, and I don't expect any real issues there. So Skier provides a hardware accelerated interface. So depending on how you use it, some people actually think that Mission Planner on Android is actually snappier than Mission Planner on Windows, which in all honesty could be partially true, mainly because of the hardware accelerated interface of Skier. So, so that's from the rendering perspective. So everything is drawn via Skier and Skier Sharp. The level above that is Mono WinForms. So like I said, the Mono project has been a submodule in Mission Planner since 2018. And it's that actually provides the user interface or all the Windows lookalike items for what Mission Planner you see on Raspberry Pi Linux and also Android, iOS, and OS X. So they are all using the Mono WinForms platform to actually render the standard basically buttons and controls of Windows-like devices, whether it be Raspberry Pi, Linux, Ubuntu, any Linux distro that currently supports running Mono. So probably the real tweak here is on Linux Raspberry Pi, it is native Mono WinForms. On the Android OS, it is a custom version of Mono WinForms, predominantly just a fork with a custom window manager at the back end. And that custom window manager is basically just talking to Skier Sharp to actually draw all the controls and render them to screen. So the advantages of doing it this way are same source with minor tweaks. It is literally the same source. Everything you see is in the Mission Planner repo. You can compile it yourself. There is a different solution to do this. So you'll notice in the Mission Planner repo, there's missionplanner.sln, which is missionplanner.solution. And then there's a Mission Planner lib.sln, which is actually used to compile the Android, iOS, and OS X versions. There are reasons behind this, and it's all to do with the Mono WinForms implementation and the fact that we're overriding a system library to achieve this. So that part gets complex. And then probably the main real differences between the platforms are the custom serial implementations depending on the platform, Bluetooth, and the native library access per platform. So as an example, GPS access on Android and iOS is technically a different API. So the ability and serial and Bluetooth, they're all different APIs depending on platform. So it's really just about creating an interface between those different APIs to interface with what Mission Planner expects, which is effectively just making Android, iOS like Windows. This may not be the best solution, but it's a solution that works. So yeah. So that's pretty much Android and iOS. Feel free to test it. It's available now for all of these platforms. It's just testing is probably the real key, and small improvements I plan for the future is currently the map doesn't support multi-touch. I do plan on adding that to the map because pinch zooming is so much easier than the current method, and a few other small things like that. Like one thing I will say is the firmware upload on Android, it does actually work now. However, getting it to work seamlessly, I don't think will ever be a real possibility. mainly because the way the libraries interact with the Bluetooth interface on Android as an example. So when you plug in a USB device into your Android phone or tablet, it will actually prompt you what app you want to use it with. And the problem here is the bootloader on, say, the Cube will only stay in the bootloader for 1 to 2 seconds, possibly less. So by the time Android's prompted you about this request, you've clicked accept, click go, normally this time has passed. So if you're quick, you can actually update firmware on a Cube, as an example, from an Android device. I have done it. It's just very hard and difficult. So long term, it's probably not an ideal solution, but if you really had to, it is a solution that would work if you're willing to put up with the pain points. Okay, so moving on. Okay, so one of the other things that's been going on in the background is HereLink and Mission Planner integration. So Mission Planner has recently added ZeroConf detection. So what this means is ZeroConf, it goes by many names depending on which platform you're on. Apple has their name, Linux has their name, and I'm calling it ZeroConf at this point in time. So it's basically network service discovery, whether it be printer, camera, and in this case, MAVLink. So as of new versions of HereLink, basically that will be broadcasting a ZeroConf showing where the MAVLink endpoint is on the network, and Mission Planner can detect this and automatically connect to the HereLink on your Wi-Fi network as an example. So if your HereLink was connected to a vehicle, then you could actually connect Mission Planner on, say, a laptop to that, or a laptop to the HereLink, and then the ability to actually basically dual control the vehicle through the HereLink. So where this comes in is basically support for video playback. So this is actually a two-stage thing. It's both Mission Planner on desktop and also Mission Planner on HereLink itself. Again, with the Android support here, and the ability to display the video play of H.264 and H.265 native on the Android using the Android APIs, not GStreamer in this case. But obviously I'll be looking to using GStreamer as this interface into the future. But that depends a lot on the support of, there's quite a few potential issues here around device support, GStreamer support for the specific device, and whether or not it supports native hardware decoding of the specific codec on that Android device. So there is a lot of variables here, and working with HereLink in this instance, I have access to those internals. So it makes things a lot easier to integrate better in that platform. So where this is also going is dual video streams. So the last three options here on this list are probably all partially related: dual video streams, gimbal control / second operator, and RC control via internal protocol and second operator. So what I'm actually saying here is a FPV camera, the person flying it on the HereLink is using an FPV camera, and then there is a secondary controller or laptop running Mission Planner or one of the other ground control stations that supports it, can actually view a second, say, camera feed or a gimbal feed independent of the first FPV feed, and the ability to control that camera separately, and basically so the pilot can fly and the gimbal operator can fly the camera. Completely independent, and basically using the dual video feed to achieve this in a safe manner, and also multiple access methods as well, whether it be HereLink to secondary HereLink or HereLink to Mission Planner on the desktop using, say, a joystick on the desktop, viewing the video feed, so gimbal control via Mission Planner via HereLink. So there's this is very close to basically being released. It's implemented from the HereLink to HereLink side. It's already implemented. The dual video stream is already implemented. The last point on this list, the RC control via internal protocol, is the only missing step, which is the Mission Planner step. So the joystick control purely to control the gimbal, which is connected to a HereLink. So that's definitely a work in progress / coming very soon. Okay, so MAVLink Inspector. I've already been through the UAVCAN Inspector. MAVLink Inspector, pretty much exactly the same thing, exactly the same UI layout. It's just the ability to show both two-way traffic. So one of the recent additions is the show GCS traffic option in this screen, which will basically show traffic Mission Planner is sending to the drone. So as an example, in the screenshot I've got here, there you can see the heartbeat being sent and the time sync message being sent. So it tells you the frequency and the actual amount of bandwidth being used to send that. So the GCS in this situation, according to that example, is only sending 21 bytes, which is 21 bytes per second, which is the heartbeat packet. And then receiving from the vehicle, we can see all those messages in there. So this is really a developer-friendly, designed for developer-friendly tool, the ability to see what's coming from the vehicle at any time, the ability to graph the numbers as they're coming from the vehicle at any time, and stuff that might not be displayed in the Mission Planner status screen. So if you do come across something that you see in this screen that you would like on the status screen, please let me know. A lot of the time, a lot of these messages, they contain excess information which isn't always used. So if you did want something extra, an example of some things that have come in recently is the generator messages and also the EFI messages. So they're an example of something that have been added to the status screen recently. And basically, if you were to give me a name and the path to the packet and the path of the field from the MAVLink inspector screen, I could add that very easily in a matter of 5 to 10 minutes and basically push a new beta and you would have it. So it's really about just making it easier for developers to get access to this information, and the ability to graph this values obviously helps a lot as well. So, and yeah, the frequency of the message, estimated bandwidth, and graphing. Again, this is count-based message. You can basically, you could tell it to plot 5,000 points, and then it'll keep that rolling 5,000 points. So yeah. So that's the basis of MAVLink Inspector. Pretty much exactly the same as UAVCAN Inspector, just for MAVLink instead of UAVCAN. Okay, so the extras. So this, on that very first screen of the new features, so this is basically a where it is, how it is, what it does. So remote data flash logging. So what I'll do is a lot of this stuff is on the Control F screen. So I'll just bring that up right now. So, and what's the bet? I'll just move this over here so we can see a bit of both. So that first option is right here. So as an example, MAVProxy and MAVLink Router can both act as a data flash MAVLink endpoint. So what this allows is Mission Planner to do the same thing. If you have a high bandwidth link to the vehicle, you can log data flash messages over MAVLink, and then it'll save it in Mission Planner logs directory, just as MAVProxy or MAVLink Router would do. So each time you click this button, it'll basically create a new log and start logging. Currently, it's an option where you need to go into Control F to do it. I think Tom was the original person that requested this, but yeah, it works, been tested, and yeah, it works as described. So next one, cursor on target. So this is a contribution from Tom as well, down the bottom here on this one. So Tom could probably talk to it more than I could. He knows all about this topic, but it's basically similar to many of the other Mission Planner secondary screens. Select an output port, select a baud rate, and it'll basically generate messages at the given frequency based on the actual vehicle telemetry information. Okay, next 3D map.
If you don't mind, I wouldn't mind talking a little bit about that. Go ahead and click on there actually on the COT, and then just click on UDP and just say connect.
UDP?
Yeah, connect. Just start going. It'll forward somewhere. So you actually see the output that it's generating right there. So because you're connected to a simulator, you get you would see the lat longs and all that update. So it's just XML. So cursor on target is something that sort of started on with the U.S. military, and it's kind of branched out into more things. But it's a format that's basically designed to encompass all formats for everything. It's like super future-proofed to describe troops on the ground, just friendlies, people, aircraft, ground, all kinds of different. It has a ginormous spec. So this is a very tiny portion of what's being announced, but it allows you to show up on other services like ATAC, which is a little Android app that is getting more adoption in civilian use with police and fire and whatnot. So with and even like antenna trackers, and so what I have right now is I use this particular feature on here where I get the data from the aircraft on MAVLink, right? And then from here, I can forward this to an antenna tracker that only talks cursor on target. So it's kind of like forwarding Nemo, where you forward the GPS information, but this also allows you to broadcast information to other devices. So people on other networks show your aircraft would kind of show up as a device. And soon I'll be adding this native into ArcherPilot itself.
Yep. So I just connected to a vehicle there so we can see real latitude and longitude as an example in there. And so that's basically live now to some extent. So what it would look like in real time. Okay, so that's cursor on target. So the next thing in here is, this is purely a demonstration 3D map. So 3D map basically just opens a nice OpenGL render window. This will take a while to render at a guess, but it does exactly what you'd expect it to. Purely a trial 3D map. So what people don't know about this screen is, so you can navigate around. It also supports clicking. So if I wanted to fly over to this point over here, I'd click on the ground over here and it'll set a guided mode waypoint. So I'll click there, it sets a guided mode waypoint over there. I'll just increase this so we get slightly better resolution. But this is a very quick example of just some of the map. So this is purely based on telemetry stream rate. So it does look very chunky, but part of the reason for going this method is it really depends on the computer you're running it on. So if you're running this on a laptop in the field, obviously you don't want to chew through battery. So it depends on your requirement as to what you're expecting with this. So purely as a demonstration, if I loaded a waypoint mission, they would actually show up as waypoints as well. It's really just purely a demonstration, doesn't actually have any further use at this point in time.
Michael, does that do, that's all Google Earth, I presume? Or where is it? Where's that from?
So yeah, it's Google Earth, and so it's basically just Google Earth imagery and SRT.
Okay, and how does that interact with the terrain?
In what? So at the moment, I'm in guided mode. I took off in guided mode, flew to 20 meters altitude, and now I'm just clicking the map. So it's just flying around in guided mode with 20 meter
altitude. What
altitude.
I mean is, would you see mountains and things? Would you see mountains actually stick up out of the ground?
Oh, yes, you would.
Okay.
I just picked a bad location to start, but yes, you would see mountains. Yeah, this area that I'm looking at is rather flat. So yes,
for a cruise mode of sorts with plane, this would be pretty amazing.
Yeah. So yeah, you can't really see a lot here, but so I just turned off lock to nav and then basically in free fly mode. So I just go high pretty much and see off into the distance. So there's water over that way, and yeah. So yes, basically a work in progress, but yeah, a few limitations based on CPU and not necessarily practical if you're limited resources out in the field, laptop, etc. Okay, so next one. The EFI/generator. So like I said, recently added messages are EFI and generator. So these now appear in the status tab under EFI underscore and gen underscore. So they're purely just to display, graph, do whatever you want to do. You can add it to the quick view. Really depends on your use case. Face map. Okay, so face map is basically, people have been asking to basically map the face of a building or something like that. So this is actually a contribution from someone else, but it works exactly the same way as auto waypoint and survey grid, but instead it's a face map. So quick example, I'll just do a very, very quick example. Draw a polygon. Let's go from there to there to there. Auto waypoint face map. So that loads a screen that looks like this. And from here, you can specify cameras, overlaps, and anything else you want. So bench height. So currently we're going to fly 30 meters high at 90 degrees off we've only got one bench, so if I added a couple more benches and then added a depth of the bench of say 5 meters, you get a nice picture here of an illustration of what it's going to do. So you can change the camera pitch. So say it was at 45 degree down, basically you can see the camera changes here as well. So it really, I'll just remove a few of these. We've got 10, not that. 10, so you can see 45 degree down, 4 benches at with a 5 meter depth per bench. So obviously, if you don't want that, you'd switch back to 1 bench, and then it's just a straight vertical up and down. So this is the ability to do, basically face surveys or whatever else you want to do. One thing a lot of people don't know is the red points in here, you can drag and change. So if you didn't get exactly where you wanted to, you can drag it around and move it as you see fit, and it will dynamically change the paths. So I'll just accept that, and there's our path. So there would be multiple altitudes there, all on top of each other, flying back and forward using do cam trig dist. So I'll just clear that. Now,
and Michael, since on that page, there's a feature that I find very useful that I think should probably become the default, maybe. But if you right-click on your screen, you can change your dock. Docking, and then when I show people that, it's like, oh my gosh, this is like, everyone should do that. This should become the default. So now you can actually see all the missions, and it's a lot easier to work in.
Yeah. So yeah, this feature has been there for years. Obviously, highlighting it here is probably a good thing. That way, people know about it in the first place. So yeah, switch docking, and if you want it back, just switch docking back. So this is the way it ships normally, but if you wanted to switch docking, you can go there and do whatever you wanted.
And also, so the ability to show the maps on your data screen as well. That's a good one.
Yeah, show everything basically.
Well, no, I mean to show your mission on the data screen.
Yeah, so there's actually 2 ways. So normally the data screen would update purely from, well, I'll just add something. So I'm connected to a copter at the moment in guided mode. So I'll just write that. So normally the data screen, it did actually display it. Okay, so yeah, once you've uploaded, so probably the key here is like, if I program this, but don't upload it, it won't display here. It has to be written to the vehicle, otherwise it won't display.
I'm sorry, I meant if you go back there and you can right click, you can go to like more of an editor, go give you more information. So go back to the data. Yeah, go back to data, the data tab, and then right click on your map.
Yep.
And
which one? I'm not quite sure which one you're referring to.
Yeah, I don't see it now. Oh yeah, flight planner.
Yeah.
There it is, flight planner.
Yeah.
That puts it there in your on your main data screen on your HUD, so you can do both.
Yes, exactly. Yep. Yeah. So that feature's been there for a very long time as well. So it really depends on your use case. But yeah, you can edit the mission while displaying it, and if when you close button up here and basically switches back to the normal flight data screen or flight planner, and yeah.
As well as you're tuning at the same time too. You can have a bar to be tuning all at the same time.
Yeah. So if you wanted to tuning, so basically say we wanted extended tuning. So trick here, double click a tab and it will pop out, switch back to flight data, switch back to flight planner, and we can program a mission, change PIDs all at the same time.
I meant the tuning checkbox at the bottom where you can plot.
Oh, you mean like this?
Yeah, then it gets fancy.
Yeah. So yeah, there's many options. I don't think that worked exactly as intended, but I should probably switch docking would have made that easier. But yes, so the ability to tune, well, there's a good example, the ability to view your tune, change the tuning values plus program the mission all at the same time from the one screen. And I know one thing that's been recently added is if you right click here, you can undock the quick view tab. So you can basically put this wherever you want it to. So if obviously the main reason for that is multi-monitor setup. So you can put it wherever you want to put it. Close it and it goes back down the bottom as you'd expect. Okay, cool. Okay, so moving along is Lua REPL. So basically you can find this under Setup Advanced REPL because people might not know this, but a lot of the stuff in the Control F screen is being relocated to this screen depending on what it is. So the stuff that is generally multi-use is being moved to this screen. It is still in the Control F screen, but in long term, it will probably be moving to this screen with a little blurb to go with it as well. So the old FFT method, the new the spectrogram FFT method I haven't added here yet, but all the other stuff, MAVLink Inspector if you wanted it, instead of having to use the Control F version. I know Tridge was requested MAVLink Mirror to be added here. So this is for basically, if you're connected to a vehicle, you can actually spit it out another port somewhere. So you're basically a mirror of the incoming MAVLink stream. And a few other options, NEMA output, which I think was used during Outback Challenge. Follow Me paramgen is an internal function for fixing stuff ups when the parameter data is bad. Moving base info anonymized log, so that's basically scrambles the Latin log in a log, so you can send it all over the internet should you choose to. And then of course what I'm actually here for is the scripting REPL. So basically testing Lua, and I know Michael DB's done a video on that prior, so I won't go into it, but have you his video is probably the best answer there. Okay. AIS support, so this got added last dev conference. I didn't do a chat last dev conference, but AIS was added during the dev conference for Peter Hall, I think it was. So that's appears just as ADS-B planes do, just for ships. So AIS support for ships displaying in Mission Planner. Next is GeoTIFF support. So adding more projection frames, so UTM, ETRS, and geographic. So geographic is the normal lat long, ETRS is a different one in Europe, UTM is global, but they all have their slightly different projection. There's still a few bits of work in progress on this one. There is a lot of different global coordinate frames. So these are the three that are supported at the moment. Geographic being the easy one, being lat long, it's exactly as you'd expect it. Okay, so the survey grid, a couple of things that have been added to that is the ability to do corridors, offsets, and lead-ins. So I will just very quickly demo this one. So plan, I'll just clear that mission since we don't care about that anymore. So I'm going to draw a polygon. So I'm going to use basically survey grid. So draw it, auto waypoint, survey grid. So the difference here is grid options. So say I was here, so cross grid, it does exactly what you'd expect. So using the angle from here, let me just turn that off first. Using the angle from here, we've got the actual grid we're drawing. If you wanted to get double the amount of data, basically a cross grid, so basically it's just the same grid turned 90 degrees. Then there's corridor, which is basically just the outline. So if you're flying a road survey, a beach line survey, power line survey, pipeline survey, any of that sort of stuff. So it just flies to the end of the line, comes back, and then flies to the end of the line. And then the biggest new one is spiral. So spiral does exactly what you'd expect. Think lawnmower pattern. That's the intent of spiral. So basically, it just generates a pattern and goes round and round in circles. So what I'll do is I'll just turn off markers so I can dynamically push this. So it dynamically generates the grid based on how you want it. So is a new feature as well. So if you wanted to do lawnmower patterns, Mission Planner has the ability, and lawnmower pattern in Rover with S-curves, I think would certainly make a very nice job of these corners here. So definitely looking forward to that. Okay, so I'll accept that, and I must have had spline turned on. Anyway, I'll just keep moving on. Okay, so that's basically, and the lead into is there was always a lead in distance. So this is mainly for plane users. Copter users don't really use lead in. The ability to specify a lead in at both ends, basically based on wind factors on the day. So the ability to overfly or fly in or give a bigger lead in path to actually get online for a plane based on bank angle or wind factors, upwind, downwind legs, etc. And then I just added this little future state down here. This is more of a sort of a question slash wonder if that would be useful, but with the ability to do remote DF logging now, is there any demand to do live FFT via remote DF logging? So you basically turn on batch sampling via remote DF logging and basically create a live FFT on the ground. Obviously the FFT is already being generated in the air. It's just whether or not there's any value in that. It's sort of a out there question. I don't know the answer.
Yeah, I've considered the same thing myself, and I might note that there's a whole bunch of other data in data flash logs which we don't ordinarily get via telemetry.
Yeah, exactly. And that's where I was heading with this as well. Like the ability, even the harmonic notch stuff, the ability to display some of that information potentially live, because it's not transported over MAVLink, whereas as soon as we go remote DF logging, it is. Obviously, the restriction being bandwidth there. I think that's probably the biggest killer at this point, depending on length, bandwidth availability. Yep. Okay. So, so I was going to do a very quick demo of GeoTIFF and DEM demo. So I've just included this link here. So this is predominantly for Australian users. If I click this link, you'll notice that from data.gov.au, you can get a 5-meter LiDAR DEM of the entirety of Australia. So quite often you can see trees, you can actually spot roads in the DEM data and other things like that just by viewing it. The only catch is this is an 86 gigabyte TIFF file. So 6.1 compressed, but uncompressed is 86 gigabyte. This obviously puts huge constraints on the ability to load this dynamically into things like Mission Planner. Although Mission Planner does try, it will actually load, but I'm still playing with proper integration to this as well, because if you notice on one of my previous slides, I had UTM support, ETRS support, and GEO. This is GDA 94. So again, a different projection system and a different altitude reference system. So a work in progress, let's just go with that. But there is obviously a plan to support that. So where this comes in, so the quickest and easiest demo I can show with this one is, let's just, so I've got these files here. So this is a very old solo log of a flight over a property, and I've used basically, so we've got this lovely TIFF file which has already been geo-referenced, and I want to use this in Mission Planner. How do I do that? So what I would do is I'll just grab the URL from that. I'll open Mission Planner. I'll just clear this. I'll disconnect for a second. So at the moment, Control F. Control F, and then there's custom GDAL. Load a custom map tile source via GDAL. So I'll click this. I've actually already got it open, so that's the path that I just loaded that TIFF from. I'll click open there, close that, and then I'll go plan. I'll just clear this for a second. Now I'm going to change the map source from Google to GDAL custom, and what you will find is it might take a little while to load because it has to load the 300 meg TIFF file in the background. So we're still in the same area. I'll just clear that, and hopefully it actually works. Seems to be having a little bit of a holiday. Yes, all of Mission Planner is having a holiday. There we go. Took a little while. So because I had that geo-referenced TIFF, which was actually referenced in geographic coordinate frames, so it had been basically all the images been reprojected to geographic, which just means it's been reprojected to latitude and longitude. So pixel density is based on latitude and longitude, not UTM or some other projection. And we can see that. So this data was captured by a GoPro on an old Solo. So it gives you a rough idea of what's capable. So this is, yeah, custom imagery on if you wanted a high resolution. So the actual resolution of this, given it was a GoPro, it's not the best resolution, but at the same time, it's certainly better than it was. So I can see that's a water tank. I can see that's a shell pool, a shell play pool, and I don't know what that is, but it's something in trees, etc. So that is basically that one. So that is for visual. Now, in actual fact, I've actually already loaded it, but what you'll notice down here is we've got SRTM and we've got the current. So as I mouse over here, so we're SRTM, as I mouse just here, we switch to GeoTIFF. So I've actually loaded a DEM, digital elevation model, for this same area. So as this data was captured, I generated a digital elevation model as well. Now, to basically add one of these, the digital elevation model again is in geographic, so the latitude, longitude. I'm going to use Control F again. So in here, there's an option called DEM. So I'll click that. And so here's the two images that I currently have loaded as DEMs in. So we have that 86 gigabyte file I was talking about earlier, which currently is not actually working correctly. And then I have my farm DEM, which is the actual DEM I'm using here. I click Open DEM Directory, and it will open basically the Mission Planner, Program Data, Mission Planner SRTM directory. So in here, I would put my farm DEM, and there's a 400 megabyte TIFF file, which is the elevation data that Mission Planner is using. So it doesn't display properly in a Windows TIFF viewer, but it works in Mission Planner correctly. So to give you a better rough idea on so yes, I know it's using the DEM data, but how do I actually really know that it's using it? So I can see down here, and when I mouse over that, it says GeoTIFF, but how do I actually know? So there's another shortcut called Control W. I've actually done a previous speech on Control W, but basically this is just highlighting. So what I'm going to do is click Terrain, and what it'll do is it'll render an overlay showing the elevation model. So as at the front of the property here, you can see trees. So the top of the tree here is 7 meters, and then if I mouse up a bit, 2.6 meters. So basically you can show the trees, you can show the buildings. The trees down the back of the property didn't work properly by the look of this, but I've just blamed that on the poor quality capture of the data in the first place. But buildings, you can see basically the edge of buildings. So the roof of this building is 7.8 meters. The ground next to it is 5.3 meters. So the ability to basically get high resolution data into Mission Planner, and then the on-flow effect of getting this into the copter to basically do terrain following or other things. So the next thing you might notice is this transition between SRTM and the GeoTIFF. So in this case, if I remember correctly, we didn't actually, I don't actually remember the reason for that, but there is an altitude shift. So as an example, the edge here is 3.3 meters, and the SRTM data is saying 6.3 meters. So there's approximately a 3 meter shift between the two. I don't recall the exact reason for that, but as an example, at the same time, if you were planning a mission on this, basically your takeoff altitude would be ground level anyway. So it depends if you're planning an absolute mission or not, and if terrain following was on. If terrain following was on, then obviously you picked a number higher than the terrain. If I remember correctly, I think there was some conversion in here that wasn't done on this image, but it's a good sample set purely because I can show the illustration of how the data transitions between the GeoTIFF and the SRTM data. Okay, so that's basically an example of that. So one thing I'll just touch on in Control W as well is elevation. So we're currently, technically, the drone is actually, oh no, I'm not flying anymore, so it won't work. Okay, let's abandon that idea. Okay, so that's basically that. Now if I go back to here, so that's a very brief example on how to use that. Are there any questions?
Yes, this is Tom Pittner again. Can you pretty
Yeah.
please make a list of all your magical hidden keystrokes?
A lot of what I showed today will be coming out probably into the advanced screen in the setup screen or on the mission planner settings screen, depending on its use case or intended use case. So, yep.
Was that a stock solo or had it had its GPS swapped out?
I think it was stock. You ask Philip that question. I don't know the answer, but it might have been stock. I'm not sure. Cool.
All right. Well, thank you so much, Michael. That was absolutely brilliant and amazing as always. You know, all of the features you've brought into Mission Planner. It really is the primary interface we've got to our users, and for many users, in a Mission Planner is ArduPilot, and seeing it develop so rapidly and so well is great. So thank you so much. So the next slot we have in our timetable is some vendor-specific talks. So we have a talk from CUAV, and so they were going to present on some of their new features. And so that's Lindy from CUAV. And just give me a second while I switch over the recording, and then I'll start it up. Are you ready to go, Lindy?
Yes, hello, I'm here.
Hello, great.
Hi.
I'll just switch over the recording
hear me?
just a second, and
Okay.
then be ready to go.